with video 2 in the series, and we're going to focus on data cleaning today, which is, in my opinion, the most important part of any research analysis progression, cleaning your data and just having it set up so that you can do efficient analysis with it. So let's just dive right in. Okay, so kind of starting where we ended the last time, but I'm in a new Python notebook. Feel free to use the one that we used from last time. I'm going to call this video 2. Okay, so super quick recap. We have to import our libraries again. So we're going to import pandas. We are going to import numpy just in case we need the mathematical functions. And we're going to import something called AST. That'll come up later, but let's just do it now. I usually like to import all my libraries up at the same time. If there are things you need to add, when you go along with your code, you can always come back up and add to this. All right, so we pressed Shift Enter, running it. And we're going to start the same way we did last time with initializing a variable that's going to hold our data frame. So I'm going to call it df for ease, and then PD, the pandas library read CSV, and it's that test clinical database. Okay, so now I'm going to do df.head to just see what we're working with. Alrighty, and so again, to review, if we do df.info, we just get the structure of our data. So we have 100 total entries in this database with 11 columns with these types. So if we pull up that head again, thinking about what we want to clean. So I see already that there are some blank values in this gender column. Again, this is a fake database I made to just ease the lesson, having something simple but still clinical appearing. But this is a very real problem that you would have in clinical data sets. I'm sure some of you have run into it. If you've worked with clinical databases before, there are sometimes blank columns or blank values in columns or things that you want to rename. To kind of fully evaluate this column, something that is very handy is a function called value counts. So let's take a look. We're going to call the column, so df, the square brackets, and it's gender. So we're going to write it exactly as it's written here. And then dot value counts is a function inherent to a pandas data frame. And what it does is it shows you the number of different unique values in a column. So in the column gender, the potential values are M for male, a blank, or F for female. And these are the numbers of how many of each are in the column. So for us, let's say I'm going to make this decision just to show a mechanism of cleaning data, but let's say I didn't want it to be this blank line. Let's say I wanted, anytime there was a blank, I want the word unknown. So how can we do that? How can we restructure our data? We can do that by this method of using a for loop and a list. So we talked about both of those last time, so they're going to come back. I'm going to name a list new gender column, and I'm going to set it equal to the way we always start lists is an empty bracket. So 2 brackets empty, because I'm going to fill that up with what I want it to be later. So then we're going to use a for loop. So for I in, and then the way we call a column again is just df square brackets and the name of the column. So this is going to iterate through every spot of the column gender. It's going to go through all of these. And so what I want, so I have to think this through. What I want to do is if it's a known value, so in this case, M or F, I want to keep it as is. I want to keep that information. But if it's a blank value with this line, if it's this blank line here, I want to change it to unknown, so it's more descriptive. So let's do that together. So I just said a lot of if statements, and so in turn, we are going to use a lot of if statements in the Python code. So what, like I just said, if I is equal to, and then let's use quotes M, because these are strings. They're just, a character. So you can just use quotes like that. So if I have 2 equal signs here, that's different than the 1 equal sign. 1 equal sign sets a value versus 2 equal signs compares 2 values. So if I is equal to M, And this statement will either return true or false. So if it's true, what I want to happen is I want to keep this M the same. So I'm going to add it to my new gender column as is. And the way I do that is by using a function inherent to lists called append. Append is how it sounds. It appends a value to a list. So we're going to say new gender call dot append I. And then I'm going to do the same situation for F. I can use another just if statement if I wanted to, or I can use something called elif. It means it's the truncated version of else if, and it will only run if this is not true. And since something cannot have both of these values at once in our case here, we can use the else if. So elif, so if this is not true, it'll bounce to this. So then if I is equal to, now let's do F, I want to do the same thing, just append it as is. And when you append I, it's literally just appending whatever spot was in that spot in the column. So new gender call dot append I. Okay. And now the only other option, since in our value counts it showed there's only 3 options here. There's only MF or these blanks. We covered all our bases already. We got the M's, we got the cases where it would be M, we got the cases where it would be F. So the only other case is that it would be these blank lines. So we can use else actually. So if it's all else encompassing, then we can just use else. So then we would say, so now it's a little different. We don't want to just append I as is. We wanted to change it to unknown. So all we're going to do is new gender call, same process, append, but instead of I, we're going to put the thing we want, unknown. Okay. And then, so this will run, and then just to test it, at the very end, we're going to print out our new gender call list. So this is that list that we made, and we just filled with this for loop. So let's do that. Let's run that. And as you can see, we seem to have what we want. So then what we can do is set this equal to the gender column here. So gender is equal to, and then we can literally just set it equal to what we made. When you set a column equal to a list, as long as that list is the same length as the column should be, and we actually can check that, so we can use another inherent function to Python called length, len, and we just put in that list, and it's 100. And so we know we got the full list out of what we did here, so we can add it to this column. So add to this column, and then I'm just going to double check myself again. Always good to double check. So what I'm going to do to double check is I am going to run that value counts object again. And as you can see up here, we were expecting 36 blanks, so there should be 36 unknowns, and we have exactly that. Okay, so the next thing we can do, so let's again take a look at our data. So task 1 done. Now we can see, we no longer have that blank, we have unknown. So great, we cleaned our gender column. Okay, the next thing I see is smoking status. I'm seeing some yeses, some ones, some zeros, some yeses. Let's evaluate smoking status. So in the same way we just did, smoking status dot value counts. Again, just because we want to see what the spread is. All right, so I see we have yes, 1, no, 0. Okay, so this is a mixed type column. We have some things, so we have some things that are words and we have some things that are numbers, but these numbers also represent the words. So 1 is yes and 0 is no, and I'm saying this because I know the data, and that's why it's important to really know where your data is coming from and be have an evaluation of what you're actually passing into your code. But so I'm gonna, since I know that the 1 should be yeses and the 0 should be no, I'm gonna make a determination that I want to have the smoking status column all 1s and 0s, with 1 representing yes and 0 representing no. I don't want this mixed type. And so the way we can do this is a very similar process to before. We want to, initialize a list use a for loop to go through the current column and manipulate it how we want to, adding the new manipulated values to our list, and then setting that list equal to our column at the very end. And so we're updating the column with the information. Okay, so easier said than done. So let's try it out together. So now we're going to have a new, I'll call it new smoke call. It equals, again, square brackets for a list. And we are going to pass in, so we're going to do the same thing that we did. We're going to do this for loop for I in our smoking status column. So I want to iterate through this column. What do I want to happen? So if I is equal to yes, I want to append a 1 to this new smoke call. So new smoke call dot append 1. And then we can use the elif again, because again, none of these are going to be true at the same time. So you can always use the else if statements. Otherwise, if it's equal to no, if I is equal to no, then I want to append a 0 to the column. And notice how I'm doing 0 and 1, literally. I'm not doing it in quotes like this. This would be a string technically containing 0, but I want it to be a number. It's usually simpler when you use numbers like this. So I just want to, whenever I could put things in number form, I like to. Okay, so then let's keep going. So otherwise, if I is equal to 1, so this looks like what we should be doing, right? If I is equal to 1, because I see a 1 here. Okay, great. The thing is, though, in Python, if there are mixed types like this, it will, I believe, default to being the type of the word. So making these 1s and 0s, they're actually contained in the single quotes because they're strings of 1s and 0s. So the way we could quickly test this to see if that's true, to see if they are strings, I'm going to do it because it'll also teach us something else about the data frames. So I see here, that's why I love always looking at my data frame. I see here that at spot 1, there is a 1. So I want to test and see if it's the 1, the number, or the 1, the string like this. So to access that exact spot, I first access the column. So df smoking status. And then the spot is represented by another set of brackets and then a number. So it's almost like a coordinate. It's essentially like this square bracket tells you the column, and then this square bracket tells you the row, 1, like a coordinate. Okay, so if I just do that and I print it out, it gives me what I want. I see it's a 1 in quotes. So I know when I'm comparing it in here, I need to also use that same thing. Great. Okay, so if it's a 1 in quotes, I want to append just the number 1. And then lastly, you could do if I is equal to 0 in quotes, you could do it like this and then append, or since it's our last option, we can just do else. So else new smoke call dot append 0. All right, so I'm going to run this, and then at the very end, I'm going to print out the smoke column just to see. I want to see what it looks like. Okay, looks like we have all 1s and 0s, which is what I wanted. And so what I'm going to do is now set the column smoking status equal to new smoke call. And then I am going to triple check myself by using value counts again. Oops, I spelled it wrong. Spelling is super important in Python. Smoking. Oh, okay. So this is great. I can show you a quick mistake I made. So again, spelling matters a lot. So here I made a typo. So all I have to do is just fix the typo, and then it should be working. Perfect. So now we have, I want to double check myself. So I should have 57 1s, right? And then 43 no's and zeros, and I do have that. Perfect. So now, because I made that typo, I think I added actually a new column to our database called smoking styles, but we can always delete that later. It's not a big deal. Great. Okay, so now we've done 2 aspects of cleaning. The last thing I want to do is dive into this column right here, the blood pressure, where you see these parentheses. Okay, so I'm going to just pull up our column again, or our data frame again. Okay, so I see this blood pressure and they're in these parentheses, and it'd be really hard for me to analyze this. Let's say I wanted to get so this is, the systolic and then diastolic blood pressure. If I wanted to get the averages, if I wanted to get the standard deviations, it'd be difficult. They're all crunched together. If I even print out one of them, so let's do DF, so it's BP, and then if I just pick spot 0, number 1 in Python is 0. That's kind of just a computer science thing, but so spot 1, spot 0. So what I have here is this parentheses of 2 numbers in these 2 quotes. Anything between 2 quotes is a string. So the type of this column is a string. However, there is something called a tuple. A tuple is 2 numbers that are linked because they're in parentheses together. So a tuple would be 1, 10, and 77 like this with no strings. So what I want to do is I want to go into this column and I want to break up the tuples. I want them to be separate, and then I want to create a new column that represents systolic blood pressure and a new column that represents diastolic blood pressure. And I want to do that so that I can mathematically evaluate them if your publication needs the average systolic pressure of a certain patient population or average diastolic, then you want to be able to get that, right? You want to be able to get that easily. So we're going to save ourselves the hassle later and do the hassle now. Okay, so that library that we imported, AST, is going to come in. So same process as before. Repetition is good. It's good for learning. So now we want to make 2 new columns. We want to make a systolic column and a diastolic column, like I mentioned. So now we need 2 lists to start. So I'm going to make systolic vowels as one of my lists, and then diastolic, and set it equal to an empty list, and then diastolic vowels and set it equal to an empty list. And now I'm going to make my for loops the same way we started before, for I in, and then we go into our column, BP. Okay, so now we're iterating through our column, and in it, I want to, again, break up these 2 numbers. So the first thing I want to do, I'm going to set a temporary variable. A temporary variable is a variable that exists only inside your for loop, and so you can only access it in there. So I'm initializing it in the for loop. So I'm going to call it temp, and it's going to equal, and we're going to use that AST library, AST dot, and then there's a function of this AST library called literal eval I. So what this does is it takes what the value appears to be and creates it in that type. So what that means is, okay, if I look at this, it should be a tuple because it's 2 numbers in parentheses, but the only thing that's stopping it from being a tuple is that it's in a string. So what literal eval does is it breaks off those quotes, breaks it out of the string, and then it saves that as the type that it represents. So if there was just, if there's just 110 between these 2 single quotes, this function would create an integer value. But since we have a tuple in the string, it's going to create a tuple value. So this is going to be type tuple. And then with tuples, the way you access the first and second spot is very similar to the way you access the first or second spot in our data frame. So we are going to call, I'm going to do sys temp for systolic temp, and it's going to be equal to temp of 0, the first spot. And then I'm going to do dias temp for diastolic temporary value is equal to temp 1. So I could do that. And then what I can do is I can add the values that I just selected out of the tuple to their appropriate spots. So to systolic vowels, I want to append that systolic temp, and then to diastolic vowels, I want to append that diastolic temp. So I didn't actually have to make these two if I didn't want to. I could just put this right in here, but why not? Keeps it a little cleaner. And then at the very end, I would like to just print out my systolic vowels and print out my diastolic vowels just to take a peek. Okay, so it looks like we're on the right page. If I really want to double check again, I'll do the length of both of them too. So use the LEN function, systolic vowels, 100, and then check for diastolic. So great, it looks like we got all the information we needed, and now we can create our new columns. So the way you create a new column in your data frame is very simple, actually. You see we have a new column here because of that typo I made, smoking stouse. So you just literally call a new column. So DF, and then just pick a name that does not exist in this, and it'll make it a new column. So I'm going to call my new column systolic, and I'm going to set it equal to the systolic values we just saved. And I'm going to do the same thing for diastolic. Diastolic. Set equal. And no typos. Okay, so run that, it ran. And then now if we look at our data frame, we have our new values there. And the very last thing I'll show you that we can do is, since we have these now, we can use the mathematical functions. So remember in the last one, we used np.mean and we passed in a list or standard deviation, that we could use those for sure by turning these columns into list with that dot to list function. Or there are some functions that are just inherent to data frame columns. So if we call data frame systolic, and let's say we want to get the mean, we can just do this. It has a dot mean function. We can do that with a standard deviation as well. And then, we can do the same thing with with diastolic. And for standard deviation as well.